Hi, this is Professor Marianne Barber. Example, evaluate the integral from 1/2 to the square root of 3 over 2 of dx divided by x times the square root of 1 minus x squared. At first glance, the integrand resembles the derivative of arcsecant. However, the difference under the radical is not the right way around, and so for this, instead we will use x equals sine theta. And of course, taking the derivative, we'll get dx equals cosine theta d theta. Let's go ahead and get the new limits of integration. So for the new limits of integration, we'll start with the 1 over 2. Solving for theta, we get theta is equal to arc sine of x, and let's compute it at 1/2. So the question that's being asked is sine of what gives you 1/2, and that would be pi over 6. Now let's do the upper limit. So here again we'll use theta equals arc sine, but instead of 1/2 let's do square root of 3 over 2. The question is sine of what gives you the square root of 3 over 2, and that would be pi over 3. Now we are ready to rewrite the original integral problem, which was the integral from 1/2 to the square root of 3 over 2 of dx divided by the square root of 1 minus x squared. Using the substitutions and the corresponding theta values, we will now integrate from pi over 6 to pi over 3. dx we saw for as cosine theta d theta. X was sine theta, and under the radical we would write 1 minus, and where x squared is, it would now be sine squared theta. Let's do some basic trig, which will give you the integral from pi over 6 to pi over 3 of cosine theta d theta, and this would be divided by sine theta, and under the square root would be cosine squared theta. Let's continue. This would then become the pi over 6 to pi over 3. You've got cosine theta divided by sine theta, and now looking at the cosine squared theta under the square root, that would simplify to cosine theta. Let's not forget the d theta. Looking at this, you get to now see that the cosines cancel, and we can write this as pi over 6 to pi over 3 of 1 over sine theta d theta. The 1 over the sine theta can further be simplified as, and what is 1 over what is 1 over sine theta? Well, that is cosecant theta d theta. Now we are ready to integrate. The integral of cosecant theta is the natural log of cosecant theta minus cotan theta, and this would be evaluated from pi over 6 to pi over 3. Let's continue. In the ln, for the first part, we would evaluate this pi over 3, that's cosecant of pi over 3, minus the cotangent of pi over 3, and we'll put all of that in parentheses, minus, evaluate the integral again, but this time, instead of at pi over 3, it'll be pi over 6, so cosecant of pi over 6, minus the cotangent pi over 6. Okay, let's compute. So this is going to be the natural log. The cosecant of pi over 3 is 2 over the square root of 3. The cotangent of pi over 3 is 1 over the square root of 3. And let's subtract. It will be the natural log. Cosecant of pi over 6 is just 2. And the cotangent of pi over 6 would be, let me think about that, square root of 3. Now let's use some log properties, okay? And we can write this as 2 minus 1, same denominator, would be 1 over the square root of 3. And because it's a minus sign, we will divide by what was subtracted, which was 2 minus the square root of 3. A little bit of algebra, and this would clean up. 2 times the square root of 3 plus 3 divided by 3. There you go.